Morning. Can everyone hear me? Okay, so last class we talked about some sets and sets operation. Now we will look at some sets identities. So if you have a set A, if you take an interset with the universal sets, you will get A back, right? Because universal set is the set of all the elements in a given question. Now you are intersected with A, then it will be all the element in A. So A intersect the universal set will be A, and A union the empty set will give you A, right? Because if you union an empty set, you did not get any extra elements. Now, if you take A union with the universal set, you will get the universal set, since every element in A is also in the universal set. And if you take the intersection with the empty set, you will get the empty set, right? Because in the empty set, there's no element in it. And we know intersection means it's the element in both of your set. So there's nothing in the empty set. Then if you take any sets, intersect with the empty set, you will get the empty set back. Now, if you take A union A or A intersect A, you will just get the A back because you have the same set. And if you take the complement of a set A, and then you take the complement of the complement, then you will get A back, right? Because complement of set A, it will be the element that's not in A. Now, if you take the complement of that, then you are looking at the element that's not in not A, then it will be all the element in A, right? So think of the double negation, right? So if you do the complement twice, you will get the origin, you will get the original sets back. Okay, and if you have A union B is the same as B union A. So the commutative law hold in the set operation. So it doesn't matter in which order you do it. Same thing with the intersection. A intersect B is equal to B intersect A. Now for the now it's also hold for the associativity law, which if you have A union B union C, computing the first two sets first, so if you do A union B first, it's the same as you doing B union C first. And same thing with the intersection, right? So if you have like A union B union C, right? If they are both union, then you know the associativity law hold. Same thing with the intersection. Now distributive law, it apply when you have A union of B intersect C, right? So you have different operation, you have union intersection, then you can distribute it. So you can distribute the A union B with, right? You have intersection with A union C. Vice versa, you can do A intersect B union with A intersect C. So that's the distributive law. Okay, there's also the De Morgan's law in the set operation. So if you're trying to negate A intersect B, then you will get if you're trying to take the complement of A intersect B, then you will get complement of A union complement of B. So if you look at that, you not only take the complement of the set, you also need to flip the operation, right? You will turn the intersection to union. If you have union, you will turn it into intersection. So this is like the De Morgan's law we did when we do the propositional logic. Right, so the most of the rule you see here, you also see it in the propositional logic. Now here is the absorption rule. So if you have A union with A intercept B, you will get A back, right? Because A intercept B means the elements are both in A and in B. Now if you union with A, that means you are taking all the elements in both A and A intercept B. And you know every element in A intercept B are also in A, and you take union of A, then you will get A back. And if you have A intersect with A union B, that means you want to find the element that both in A and A union B. Well, you know that every element in A is in A union B, right? Because union will take all the elements. And when you take the intersection of it, element in both, that will be A. Okay. And if you take union with A with its complement, this means you take every element in the set, union like with all the element that's not in the set, you take complement of set A, then you will get the universal set. You will get all the element in a given question, right? Since you are taking all the element in the set and not in the set, and that will just be everything. I see people asking, what does complement mean? Complement means, right, if you see like a set with the bar on the top, that's the complement, and that means the element that's not in a set. Right, so if you look at it here, where we define the complement here, the complement of set A denoted as A bar, it will define all the elements that's not in A respected to U, which means you can think of it U minus A. Where the universal set, it's all the elements in a given question. So here's an example. If you have 3 set A, B, C, then the universal set will be all the elements in the given problem. So all the elements here. So we have 1, 2, 3, 4, 5, 6, 8, 9. Then the complement of A, it will be all the elements that's not in A. And the element that's not in A, it will be 4, 5, 6, 8, 9. Are we good with this? Okay. And if you take intersection of A intersect A's complement, then we will get the empty set, because you are looking for the element that's both in A and not in A, and there are no such element, then you will get an empty set, a set of nothing. Any question on the identity law here? If not, we will move on. Okay, so here, where we know this is the De Morgan's law. right? So let's say we want to prove this De Morgan's law. So there are different ways we can do it, right? So let's try to do it from the definition first, right? So if we want to show two sets are equal to each other, right? If you remember, to show let's say set S is equal to set T, then you need to show S is a subset of T and T is a subset of S. You need to show they are subset of each other, which means you need to show every element in set S also belongs to T and every element in T belongs to S. And this way you show that they have the same element. Okay, so if you look at here, right, so let's say we start with, we want to show A intercept B's complement is a subset of A's complement union B's complement. So we want to show that every element, if you take an element from A intercept B's complement, you want to show this element will belongs to A's complement union B's complement. Or if X belongs to A intercept B's complement, this means your X is not in A intercept B. Right, so if your X is not in A and B, this means your X is not in both A and B. Do we see that? Now, how do we contradict it? Now, how do we have an element that's not in both A and B? That means if your X is not in A, then it cannot be in both A and B. Or you will have X is not in B. Right? Because if your X is not in B, then it cannot be in both A and B. But in order to be in both A and B, you must be in B and also in A. But since you're not in it, that means you are not in at least one of it. Any questions here? And then X is not in A, it means X is in A's complement. Or X is in B's complement. Then the or, we know X is in A's complement, or means union B's complement. So we show that if you take any element from A intercept B's complement, it will belong to A's complement union B's complement. Any questions here? Okay, so that's the first part. And we also need to show that the right-hand side is a subset of the left-hand side. So we need to show A's complement union B's complement is a subset of A intercept B's complement. So we will take an element from the left-hand side. So we will take the element from A's complement union B's complement. And this means X is in A's complement, union means or, X is in B's complement. Then this means X is not in A or X is not in B. Now, if X is not in at least one of A or B, then X will not be in A So if you look at, so let me just write the explanation here. So here we have X not in A or X not in B. So this means X cannot be in both A and B, right? Since you know X is at least not in one of them, then X is definitely not in both of them. Then we have X is not in A intercept B. Then we have X is in A intercept B's complement. Now, since we show they are subset of each other, then we show that A intercept B's complement is equal to A's complement union B's complement. Any questions here? Okay, so this is the subset method that we are using. We want to show that these two sets are subset of each other. Okay, so let me write down like some rule you can use. So first of all, if we want to show that A, if we want to show that A equals to B, then we need to show that A is a subset of B, and now let me use S and T instead. And if you take an element in A, in S union T, this means X is in S or X is in T. And if X is in S intersect T, then you have X is in S and X is in T. Now, if you have X is in as complement, this means X is not in S. Let's see what else do we have. We can also have S minus T. X minus T means we have X is in S and X is not in T. Any questions here? Okay, so this is where you can use the for the subset method. Now, if you look at the and or, and also like the negation, we know that we also seen those terms in the logic, right? We have notation for and or, right? The conjugation, the conjunction and disjunction. So let's say we have S the S to be the set as all the element as X belongs to S, right? This is how we can represent a set. Then we know that if you have X belongs to A union B, this set is the same as X in A, and we know this is OR relation, so you can have the conjunction, or X is in B. Same thing if you have X is in A intercept B, then you will have the element where the X is in A and the conjunction X is in B. Now, if you have X where X is in the S complement, then you can write it as X is not in S. So this is one way you can write it, or we know about negation, right? So this is also the same as X is in negation of X in S. So this is saying that your X is not in S. So here you have the X is in S and then you negate it. So this means X is not in S. And if you have X, it's in S minus T, then you can have it as X is in S and X is not in T. Or you can write it as X is in S and negation of X is in T. It's supposed to be X. Any questions here? Now, the reason I list this out is now you can look at those rules as like a reference, so you can use it to prove the two sets are equal to each other. So if you look at here for the subset method, right? So you will start taking an element from the left hand side, and then you want to show this element is eventually on the right hand side. Then start from here, you have x is in the complement of something, and complement of something that means x is not in it, right? So and so on. So you can use the rule we have here, right? The relation here to show your work. Now, if you look at it, to use the subset method, you need to show the left-hand side as a subset of the right-hand side and vice versa. So you kind of doing the process twice. Now, if you compare the work here to showing that the left-hand side is a subset of the right-hand side and the vice versa, so it's pretty much doing the work backward, right? So if you're doing it backward, you will get the other side. So it's kind of you doing the duplicate work. You were doing the work twice in different order, but it's necessary here because you need to show they are subset of each other. So if you to make the work shorter, like we can use different methods. So instead of using the subset method, we can use the propositional rule, or you can say we can use the identity here, but to show they are equal to each other. Now, if they are equal to each other, you don't need to show both ways since they are equal to each other. Equal sign means they're equal to each other. So for the same question, let's say we want to show they are equal to each other. That means you will start with x intercept b's complement. Now this means all the element where x is in A intercept b's complement. So you write that as a set notation. And then we know x it's in A intercept b's complement, then you can write that as negation of x is in A intercept b. Right, that's one of the rule we have here for the negation. And then if you remember, we have the intersection. So for intersection, you can write that as the conjunction. So we have x, you have negation of you have x is in A and x is in B. Now you will negate the conjunction, so De Morgan's law. Then you will have negation of x in A, or where you flip and you will negate x in B. The negation of x in A, that means your x is in A's complement. Or you have negation of x in B, so that means x in B's complement. Now here you have a disjunction. And disjunction means you have x is in A's complement or B's complement. And that will give you like all the element in A's complement union B's complement. So that will give you A's complement union B's complement. Then you don't need to show both ways because they are connected with all the equal sign. Equal sign means it goes both ways. They're equal to each other. Any questions here? So this method is we apply the existing identities. Okay, now since we bring back the propositional logic, if If you remember, when we do propositional logic, to show the propositional logic, like there are to show that the some propositions are equivalent to each other, besides using the identity, we also use the truth table, right? So if we can use the existing identity, then we can use something similar with the truth table. So here we will, then for the sets operation, then we will call it the membership table, which is similar as the truth table. So to show that this two sets the same, then you need to show that their membership need to be the same. So if you look at here we have two sets. We have set A and set B. Now we will use 1 to represent X is in the set. And with 0 to represent X, or the element is not in the set. Okay, so since we have two sets here, we can have the element in both sets, or we can have the element in one of the set, and we can have the element that in neither of the set. So there are 4 combinations. Now to compute A intercept B's complement, then we need to look at A's intercept B. Right, so in order to be in A intercept B, that means your element need to be in both sets, both set A and set B. So if you look at here, right, you need to have an element in both set A and set B, so it need to be both 1. Now, if one of the element is not in both set A and set B, then it's not in A intercept B. So it's not in here, here, and here. So you have 0 everywhere else. Right, because if you look at the second row, it's in A, but not in B, so it cannot be in the intersection. Now here it's not in A, but in B, so it cannot be in the intersection. And if it's not in A and B, then there's no way for it to be in the intersection. So here we have the A intercept B. Now we will look at A intercept B's complement. Complement means it's not in A intercept B. So if it's in A intercept B, then it will not be in the complement. Now, if it's not in the A intercept B, then it will be in the complement. So it will be opposite what you did there to have 0, 1, 1. So we finished A intercept B's complement. Now we will look at A's complement union B's complement. So we look at A's complement. So that will be complement of A. So you will get 0, 0, 1, 1. And then we also have B's complement. Then we have 0, 1, 0, 1. And then we will take the union of complement of A and complement of B. Now for union means as long as it's in one of the set, then it will be in the union. So if you look at 0, 0, it's in neither of the set, so it's 0. You have 0, 1, so that means it's in set B. So if it's in set B, then it will be in the union. You have 1, 0, so it's in A's complement. So it will be in the union. And you have 1, 1, that means in both sets, then it's definitely in the union. Now, if you compare it, all right, so for the A intercept B's complement, you get the element right here, you have 0, 1, 1, 1. And for the A's complement union B's complement, then you also have 0, 1. So if you look at it, they are the same. So you have A intercept B's complement equals to A's complement union B's complement. Any questions here? If not, let's look at next example. So let's prove that A union B intersect C's complement is equal to C's complement union B's complement intersect with A's complement. So how do we want to prove this? Which method do we want to use? Anyone? Okay, I see people say propositional proposition equality, which we will apply the existing identity. Okay, so let's say we start from the left hand side. So we start with A union B intersect C complement. So this means we are looking at sets where X belongs to A union B intersect C's complement. Then we can write this. Since you have the complement, then you know you are negating X is in A union B intersect C. And then you have the union there. Then you know you are negating X is in A. Union means or. They have X is in B intersect C. Again, we are negating them. So to negate them, we will apply the De Morgan's law. So you have negation of X in A, and then you will negate the disjunction to conjunction, and then you will negate X is in B intersect C. Now if you look at here, negation of X in A, that means X is in A's complement. And here you have a negation of X in parentheses, so you have negation of X in B. Intersect means and X in C. Now to negate it, you apply the De Morgan's law again. So you negate X in B. Now you also negate the disjunction then to the conjunction. And then you will negate X in C. And that will give you X is in A's complement intersect way. So you are negating with x in B, so that means x is in B's complement, or x is in C's complement. Now we also have the commutativity law, so you can have x is in B's complement, or x is in C's complement, and x is in A's complement. And then here we will swap the order. Right, so this is the commutativity law. So here we have x is in C's complement, or x is in B's complement. So that means C's complement union B's complement, and x is in A's complement. So you have x is in C's complement union B's complement intersect with A's complement. So that will give you C's complement union with B's complement intersect with A's complement. Any questions here? Okay, now let's look at a summary of how to prove set identities. So we know there are three methods. One is the subset method, where you need to show that each side of the identities is a subset of the other side. So you need to go from left to right and right to left. So you show left-hand side is subset of the right-hand side, and also right-hand side is a subset of the left-hand side. So that's the subset method. And for the membership table, is you list out all the possibility for each set, and then you will check on each element are in all the sets or not, and then you just look at all the possibility, and then you show that the table for, or the column for your two sets on both sides are the same. And then applying the existing identities, which you will start with one side, and then you will transfer it into another side using a sequence of steps by applying the established identities. So pretty much we get it from the same as the propositional logic. Any questions here?
Professor, can you go back?
Mm-hmm.
The bottom, I don't think it's visible. The very last row.
Okay, so let me Can you see it now?
Yes, I
Is it-
got it.
Okay. Okay. Then we will move on. Now we will generalize the union and intersections on a collection of sets. So if you take union of a collection of sets, then the sets contain the element that that are members of at least one set in the collection. So if you just union a bunch sets, then your union of this collection of sets will equal to, it will contain all the element that belongs to at least one of the sets that you are union with, right? It should make sense here, right? Since you are taking the union. And the intersection of a collection of a set, it will be the set contain the element that are members of all the sets, right? That belongs to all the sets. Right, so if you look at a Venn diagram here, so if you have three sets, A union B union C, it will be all the shaded part. So as long as your element in one of the set, it will belongs to the union. Now for the intersection, right, if you have A intersect B intersect C, then your element need to belongs to all the sets in order to belong to the intersection of those sets. Right, so you can have, so here you have three sets, and then it will apply to when you have 4 sets, 5 sets, or more sets. Okay. Now let's look at some example. So let's say I give you some sets where A1 is equal to the sets 1, and then A2 it will equal to sets 1, 2, and then A3 will equal to the set 1, 2, 3. Okay, and then A4, it will give you the set 1, 2, 3, 4. Now you get this pattern. So AI will equal to the set 1, 2, 3 up to I. Okay. Now if I ask you, what's the union from I equals to 1 to 3 of AI? I see people saying that we just be A3, right? So if you look at it, right, if you take the union from A1 up to A3, so that means you will take union of A1, union with A2, union with A3. So you are looking at all the elements that belongs to these 3 sets. So you have 1, 2, 3 are elements in these 3 sets, and that will just equal to A3. Yes. Now, what if you take the union where I equals to 1 up to n, where n is an arbitrary number? Okay, so this will just equals to a n. Why? Because it will give you the element from 1 to 3 up to n. Now, what if you have the union from 1 up to infinity of AI? Now, again, you can't give me a infinity because infinity is not a number. What does this give you? The set of all positive integers. Okay. Now let's look at the intersection. If you take the intersection from 2 to 4 of AI, what will the intersection give you? So that will be A2 intersect with A3 intersect with A4. Okay, I see people say A4 minus A1. If you do A4 minus A1, A4 minus A1 will give you the set 2, 3, and 4. Is it the answer 2, 3, and 4? Again, if you look at A4, A4 have the element 1, 2, 3, 4. And the A1 have element 1. So if you subtract it, that means you take out the 1, you will have 2, 3, and 4. All right, so the intersection means the elements in all the sets. So we have element from A2 to A4. So we look at there's 3 sets. What are the element in all 3 sets? A2. Right, so the element in all the 3 sets is 1 and 2. So the answer will be A2. Okay. Now if I take intersection from 1 up to n, where n is a number greater than 1, what would this equal to? Right, so it will just be A1, right? Only 1 is in all the sets. But because you start with A1 union A2 union A3. But A1 only have 1 element. So there will be no other element in A1. So your answer will just be 1, right? The set containing 1, so that will just be A1. Now, if you have the intersection from 1 to infinity, okay, so people say still A1. Now, if I change it a little bit with I going from 5 to infinity, okay, so it will be A5. Any questions here?
Yeah, repeat that part again.
The last example here,
No, the first one. With the two.
this one.
Yes.
Okay, so if we take the intersection from 2 to 4 of AI, that means we are taking the intersection of A2, intersect with A3, intersect with A4. So that means we are looking at the intersection of these 3 sets. Now, what are the elements in all all the three sets. Do you see they all have 1 and 2 in common? And that's the only element belongs to all three sets. So the intersection here will be the set containing 1 and 2, which just equals to A2. Good?
And where it says A4 minus A1, you got
Okay,
2, 3.
that's just an answer someone gave earlier. So I'm just saying that A4 minus A1 will give you 2, 3, 4, right? Because A4 will give you the set of 1, 2, 3, 4, and then A1 it's 1. So if you just take A4 minus A1, that means you are looking at all the element in A4 but not in A1. So in A4 that means 1, 2, 3, 4, but you also need to subtract the element that belongs to A1, which is once you get rid of 1, then you left with 2, 3, 4.
You got rid of the 1 because the 1 isn't common, right?
No, I get rid of the 1 because I'm subtracting set A. So I need to get rid of the 1 if there's an element in here.
Oh,
So yeah, so if you subtract something, that means you want to get rid of the element that's both in A4 and A1.
okay.
Good. Now if I ask you what's A1 minus A4? That have nothing to do with the intersection or the union here. That's just looking at the difference of two sets.
It will just be 1 then?
But okay, so you are looking at A1 minus A4. So this is A1, this is A4. That means you are looking at the element that's in A1, but not in A4. Anyone? What's A1 minus A4 give you? Okay, I see people say the set of 1. Is 1, if is the element 1 belongs to A4? Is the element 1 here belongs to A4? Yes, right? This is 1, the element A4. So you cannot have 1 in your set. Because if you look at here, A1 minus A4, since you are minus, or since you are subtracting the A4, that means you cannot have any element in A4 in your set. So if you look at your set, so if you look at your A1, you only have 1 in your element, and this 1 also belongs to A4, then you will get empty set. So if you're doing the subtraction, right? If you have if you're doing A minus B, that means you are looking at the element in A, but that's not in B. So you need to get rid of the element in B. So if I draw a Venn diagram, okay, so let's say here is your A and here is your B. Then your A minus B is equal to this. We see that? So A minus B means you are looking at the area that's in A, but that's not in B. So if there are some element in A that also belongs to B, then you need to get rid of it. Is that clear? So if you look at the previous example, Your set A only have element 1. This 1 is also belongs to B. Okay, here is, okay, let me just use A1 and A4. And then you have 2, 3, and 4. Then what are the element in A1 minus A4? A1 minus A4, that means this area, but you have nothing in this area. So it's the empty set. We see that? Okay, so let's look at another example. Now let's say I let A1 equals to 0. And then I let A2, no, I let A1 equals to the set of all integer. And then I let A2 to be the set of all even number. So it will be 0, 2, 4, 6. A3 will be the set of all the number that's divisible by 3. And then A4 will be all the number that's divisible by 4. And so on. Then AI will be the set of integer or the set of multiple of I. Right, so if you look at it, A1 is the set of all integer, A2 is all the multiple of 2, all the number that's multiple of 2, or the even number, the number that's divisible by 3, by 4, and then by I. Right, this is AI. Now, if I ask you, what's the, if I take the union of I from 2 to 4 of AI, what do we get here? You can describe the set. Is it all the even integer? Right, if you look at AI, that means we will get A2 union A3 union A4. So A2 give us all the even integer, but if you look at A3, we have 3 here. Oh, we here we have A3 here, A9 here. They are not even number. So the sets that's divisible by 2 or 3, and I see people say all 4. Does all the number here divisible by 2? Then do we need to say it? If we already say the number divisible by 2, do we need to say the number also divisible by 4? No. Right? So that will be, so this will be the set of integers divisible by 2 or 3. Now if I look at the intersection of 2 to 4, that means have A2 intersect with A3 intersect with A4. What are the number they have in common? If you use words to describe it, then that would be what? So if the union here is the set of integer divisible by 2 or 3, I mean before we have or 4, 2, 3, or 4, then what does intersection here mean? The set of integers are divisible by both 2, 3, and 4. But your number need to be divisible by 4 as well. Right. Now, if a number is divisible by 2, is it divisible by 4? Okay, so I see people who say divisible by both 2 and 3. Well, if you look at number 6, it's 6 belongs to A4. Is 6 divisible by 4? No. So how should we fix it? Is every number divisible by 4 here divisible by 2 here also divisible by 4? No, right? So in other words, if I ask you what's A2 intersect with A4? It will be the number divisible by 4. So how would you describe the set? So your number need to be divisible by 2, 3, and 4. Now we know every number divisible by 4 also divisible by 2. So when you take the intersection, it will be the number that's divisible by both 3 and 4. A number that's divisible by both 3 and 4, it will be or the number that's divisible by 12. So this will equal to the number that's divisible by 12, which we can just write as A12. Do we see that? Any questions here? Okay. What does A1 minus A2 give you here? Odd integer. Right, so you can think of odd number. Okay, because the A2 here give you the set of even number. Okay, so you can play around with the sets here, looking for the union or generate some sets and then just practice the sets operation. Okay, and we will end the class here, and we will move on to function next class. Okay, so definitely get used to all these sets operation, because when we move on to functions, we will refer back to the sets. Okay, have a nice day, and I will see everyone next week.